Hey team, in this video we're going to look at the Algorand Quick Start project. You can see here under the specific Algorand chain where the goal of the Quick Start is to adapt the starter project and start indexing all the planet token transfers. What are planet tokens? Well, if you go to planetwatch.io, you can see that planets are utility tokens issued on the Algorand blockchain. The planets are earned when a sensor sends valid air quality data to PlanetWatch. The first step when creating a project is to check that we've got the required prerequisites. So navigating again to the Quick Start here, you can see under Create a New Project, we'll look at the prerequisites where you can see we need Node, Docker, and the SubQuery CLI. Let's do a quick system check in VS Code here, where I can run node-v, and you can see I'm running version 20.3.1. If you don't see a version, it means you don't have Node installed, so head over to Google and download it. If you're using Brew on a Mac, you can run brew install Node as well. After this, you will need to install Docker, which again you can download via a Google search. And then the last step is to download the SubQuery command line interface or the CLI, which you can do by running npm or node package manager install globally subql/CLI. Note that you do need to install Node first because the package manager comes with Node. Once this is complete, jump into your terminal and run subql-v, and you should see a version appear. I'm using 1.11. And once you have all of these installed, we're now ready to create our first project. To create a project, we want to run the Subql Init command. We can then provide a name for the project, such as planet token example, and then I'll be presented with a list of network families to choose from. I'm going to select the first one here, Algorand, and then select the Algorand network, and then the Algorand starter template project. All of a sudden, you can see some files and folders appear on the left-hand side here, which is the framework or the scaffold of the project. Next, I can provide my own RPC endpoint or accept the default in yellow. I'll just hit enter to accept the default, and I'll do the same with the remaining options here, the author, the description, etc. And before you know it, I've got my sample project ready to go. After we've initialized our project, we want to download all of our project dependencies, and to do this, we want to cd into the project directory here, and then run yarn install. This will generally take about 30 seconds depending on your internet speed, so see you after this is finished. The first file we are interested in is the project.yaml file, also known as the manifest file, and this can be viewed, once I open it up, as the entry point into our project, defining most of the details of how SubQuery will index and transform the chain data. It also indicates where the data is coming from and to what chain events we are subscribing to. You can see at the top here, we've got our spec version, the name of our project here, the description down here as well, and other fields that are defined in the documentation. The schema field here points to the location of the schema file, the next file we'll be looking at shortly, and the network section here defines things like the chain ID, the RPC endpoint, and also optionally a dictionary that can be used to help speed up our indexing. Now, all of these fields, they don't have to be changed, but the next section, the data sources, needs to be updated as it will be different for our project. So let me jump into the documentation quick start guide here, and in the manifest file section, I'm going to copy out the data sources, and then I'm going to replace it and then save it. The data sources section here defines the start block that you can see here around about 8.7 million, which is usually the block where data first appears. Then we have our handlers down below, and these are effectively functions that get triggered when the project encounters a match on our filter. So what we're seeing here is that we're going to be running a handled transaction mapping function whenever there is an Algorand transaction that includes the asset ID of this number below and is sent from this particular address. The transaction type here distinguishes the type of the transaction as an asset transfer transaction. And to get more information, you can go ahead and check out the documentation. Down here we've got the manifest file, and this goes through and talks about the top level specs, the schema, the network, the runners, and then scrolling down it also goes on to the data sources section describing the different handlers that are applicable. So very useful to become familiar with. The second file of interest that we need to change is the schema file. The schema.graphql file that you can see here is essentially a file that determines the shape of the data that we want to extract from the blockchain. So let's jump back to the quick start here, and I'm going to copy the sample schema here, and then I'll paste it into our existing file. Let's overwrite it, save it. And you can see here we've got two entities. We've got the transaction entity and the address entity. These are effectively database tables where the fields are the actual columns. Now what's interesting about this schema file is that the two entities are related to one another. You can see that sent transaction and received transactions are of type transaction, essentially making this a one-to-many relationship. There's also a derived from field, and if we jump to the documentation, scrolling down to the GraphQL schema section here, I've already got it open here. You can see that if I scroll up, each entity should define a required ID field with the type ID with an exclamation mark, effectively serving as a unique primary key. Then there are several scalar types that are supported that you can see on screen here, and also there are relationships that you can have between different entities. On the side here you can see we've got one-to-one, one-to-many, many-to-many, and the reverse lookup as well. If I go to the reverse lookup, you can see this is using the keyword at derived from, and it points to the reverse lookup field of another entity. What this basically does is it creates a virtual field on the entity that can be queried upon. So you can see the example here where the transfer from, this one here, is an account which is accessible from the account entity here by setting the sent transfer or the received transfer as having the value derived from the from field. The last file that we want to modify is called the mappings file, and you can find it in the source mappings folder, and it's called mappinghandlers.ts. So let's go back to our quick start and scrolling down in this page here. Let's go and copy out the mapping function and we'll paste it into our project. We select all, delete and paste. And what you can see here is that the file first imports some interfaces, some classes, and it defines a handled transaction function. This function receives an argument called tx of type Algorand transaction, and it's this argument that contains the blockchain data. We then do a quick test to ensure that our address entity exists. If it doesn't, we create a brand new address, and then down below here we go ahead and create a new transfer entity where we extract the ID from tx.id, we get the block height, the sender ID, receiver ID, etc. as well. And then finally we call save on our transaction entity object. To build our project, we first want to run yarn code gen, like so. What this does is it fetches the GraphQL schema and generates the associated type scripts. Hence, the outputs you can see in the newly generated types folder has an extension of .ts. Next, let's run yarn build. This creates a distribution folder performing things such as code optimization, preparing for development. Finally, we can start the project with yarn start docker, and remember to have Docker running. You can see I've got this in the background here, and it's going to start downloading the various images and get the node up and running. With this running in the background, let's go back to our documentation here, and scrolling down, I'm going to copy out a sample query, and then I'm going to go to localhost 3000, otherwise known as the playground, and then I'm going to paste the query in and then run it, and it may take a minute or two for the blockchain data to be indexed, so let's give it a second before trying again. And there we have it. We've got some data coming back here, and if you want to double check this, what we can do is copy the ID and jump into the Algo Block Explorer here, and I'll do a search for this particular transaction. And what you should be able to see is that the amount is 0, which equals here. And then the address, you'll notice the sender and the receiver has exactly the same address here. It's ZW3I, ZW3I, ZW3I. So there you go. A very quick example of how to index all the Planet token transfers from Algorand.